This is the Honors Math 2 Unit 3 review. And for the first few problems, it asks to state the postulate or theorem that you'd use to prove each pair of triangles congruent. If the triangles cannot be proven congruent, then you write not enough information. So on the first set of triangles, notice whenever you have two lines crossing, you automatically get vertical angles congruent. So these two angles that I am drawing are congruent. We have a side length on the left side congruent to another side length on the left side, but that's an issue because what we want is corresponding sides from one triangle to the other triangle, and we don't have that in terms of side lengths. So we know the left side's an isosceles triangle. We also know the right side's an isosceles triangle. But all we know in terms of corresponding sides is that one angle is congruent to one angle in each triangle, and that's not enough information. You might be tempted to say side angle side in this one, but that would be wrong because we don't have that correspondence. So not enough information on number one. On number two, there's a couple things you want to notice here. First of all, the two triangles, the one above and below, share a side. So that side corresponds from one triangle to the other. Also, we have parallel sides. And when you have parallel sides, look for alternate interior angles because those are congruent. So I will draw them, this one and this one. Those two angles are congruent and they're corresponding. And then they're both right triangles. And so again, we have another angle, a right angle corresponding with a right angle. So we have angle, angle, side congruence. On number three, again, notice we have a shared side, and then we have corresponding angles. We got one at the top here, corresponding with the bottom there. Again, two with the two on the bottom. So the order here would be angle, side, angle. Number four, you have two lines crossing, so whenever you have that, you're working with vertical angles that are congruent. Looking at corresponding angles and corresponding sides, we have angle, side, angle congruence. Number five, we have a shared side, and we have correspondence. We can say one of the lengths in the triangle on the left corresponds to one of the lengths in the triangle on the right. Again, we have the left corresponding with the right, so we have side, side, side. Number six, again we have a shared side, and again we have side, side, side correspondence. Number seven, we have two right triangles. The right angles correspond with each other. Also the hypotenuse of each, the longest side or opposite the right angle, are congruent. And also we have one leg that's congruent, and so we call this the hypotenuse leg congruence. On 8, we have a side corresponding with a side and another side corresponding with another side, but we know nothing about the third side and we know nothing about the angles. They look like they're congruent, but looks don't cut it here. So there's not enough information in 8. In 9, we have overlapping triangles. When you have overlapping triangles, it's nice to separate them. So the one I'm outlining in blue, I'll redraw here. It's a right triangle, and that's marked here. And then the one in in green here. It's also a right triangle. Also has a matching side there. Whenever you have overlapping triangles, they're either going to share a side length or they're going to share an angle. And in this case, they're sharing an angle. I'll highlight where that shared angle is. And so those two angles that I'm highlighting are also congruent. And so we have angle, side, angle congruence. Moving on to number 10. Here we want to find the values of x and y. And if you look closely at number 10, you'll see that two of the side lengths are the same. So this is an isosceles triangle. And if you have two side lengths the same, the two angles opposite those side lengths are also the same. So the 65 degrees and the angle y are congruent. So we could say angle y is equal to 65. And then we know all three angles in a triangle add up to 180. So x plus, well, we have 265, so 65 plus 65 equals 180. 65 plus 65 is 130. Subtract 130 and you get x is 50. So we found x and we found y. 11. If you look at the bottom triangle, again it's isosceles, and so the angle 59 is going to match the other base angle, so I'll put 59 there. And all three angles in that bottom triangle are going to add up to 180, so we have 59 plus 59 plus x is 180 degrees. 59 plus 59 is 118. And subtract 118 from both sides, and we're going to get 62. Now, angle x is vertical with an angle in the smaller triangle, so that angle in the smaller triangle is also 62 degrees. And that small triangle is also an isosceles triangle, and so the base angles are the same. So we have two of the angles that are equal to y, so y plus that vertical angle that's equal to x, which is 62. So these are the three angles in the smaller triangle, and those add up to 180. If we subtract 62 and add the two y's, we get 2y is equal to 118, and then divide by 2, and you get y is equal to 59. So x is 62 degrees, y is 59 degrees. On number 12, notice all three angles are congruent, and so this is an equilateral triangle, meaning all three sides are equal. And so each side length is going to be 24. So we could say 2x is equal to 24, giving us x is 12. Also 3y is equal to 24, giving us y equals 8. Number 13, all three sides are the same length. Again, it's an equilateral triangle. And equilateral triangles are equiangular, meaning all three angles are equal. In fact, if all three angles are equal, Do you remember what each angle measurement is going to be? Each one's 60 degrees. Equilateral triangles is 60, 60, 60. All 60 plus 60 plus 60 adds up to 180. So all my angles are equal to 60 degrees. So that x plus 20 is equal to 60, giving us x is 40. And the 4 times y is also equal to 60, giving us y equals 15. Number 14, we have two triangles, CGI and MPR, that are congruent, and we want to name all the pairs of corresponding congruent parts. Well, triangles have 3 sides and 3 angles, and so we're going to have to make 6 different statements. So first, for the angles, so angle C is going to be congruent to angle M. The ordering of the letters matters because C is the first letter. It has to match the first letter in the second one. G is our second letter, so angle G is going to be congruent to angle P because that's the second letter in the second statement. And angle I will be congruent to angle R. If you need, you can draw 2 triangles to get a visual. CGI, MPR. But even when you're drawing those, you need to make sure the C's and M matches, the G and the P matches, and the I and the R matches, because of the ordering of the letters. In terms of line segments, CG is congruent to MP because those are the first 2 letters in each statement. CI is congruent to MR because that's the first and the third letter in each statement. And the GI is congruent to PR because that's the second and third letter in each statement. Name a pair of overlapping congruent triangles in each diagram, and then state whether the triangles are congruent by side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse, leg. So on 15, when you have overlapping triangles, you want to separate them. And so when I'm highlighting in blue, here's J, M, and L. And then the other one, I'll trace in green. And I'm going to redraw that one beneath it maybe. We have N, L, and K. Now whenever you have overlapping triangles, they either share a side or an angle. You have to locate that. And here they're sharing that side, that angle L. So I'm going to mark that on each triangle. And then I'm going to mark what's given. So they give us a LM, this length, is congruent to LK. And they give us a LN is congruent to LJ. So these are congruent by side, angle, side. But we also want to, it says to name a pair of overlapping congruent triangles. So we're going to give a congruent statement. Triangle JLM is congruent to triangle, now be careful here, J would go with N, so N, L, K, in that order. The order I choose for my first triangle, JLM, I could have chose LJM or MLJ, doesn't matter. But once you establish that first order, the second order has to line up with the first one. 16. Again, we got two overlapping triangles. One I'm tracing in blue, I'm going to rewrite. We have A, B, C. And now the one I'm tracing in green. D, C, B. What do they share? Do they share a side or an angle? Here they're sharing side BC. So I'm going to mark that on each one. That part won't be in the givens. You have to just notice it. And then go to the givens and see what matches up. So angle ABC, that's this angle here, is congruent to angle DCB. And angle DBC is congruent to angle ACB. So we see that both triangles are congruent by angle side angle. And then let's come up with a congruence statement. Triangle ABC is congruent to triangle, now what's going to correspond with A? It's going to be D. It's going to be DCB. Okay. Number 17. Got two overlapping triangles. So here's one of them. Got an F, E, C. And an F, D, C. What do they share? They share the side CF. Mark that on both triangles. And then mark the givens. So angle E matches angle D. And it also matches angle DCF. And it also matches angle EFC. So angle side congruence. And triangle CFE is congruent to triangle FCD. One I'm tracing in blue. I'm going to write first. It's a right triangle. H, I, J. The second one, also a right triangle. G, H, J. What do they share? They share a side, HJ. Mark that on both triangles. And then what's given? HI is congruent to JG. These are both right triangles, corresponding congruent hypotenuse, corresponding congruent legs. So these are congruent by hypotenuse leg. And we can say triangle IJH is congruent to triangle. Well, I is where the right angle is, so G. And then J, I to J, that's the side length that we don't know. So I'm going to go G to H, and then to J. Alright, number 19, we have a proof. And here we're given that BD, side BD is a perpendicular bisector of AC. And we want to prove that the two triangles BAD and BCD are congruent. And so we have, like a two-column proof with statements on the left and our reasons on the right. And when we make these two-column proofs, the first statement you're going to make is the given. So first statement, just copy that down. BD is the perpendicular bisector. Of AC. The reason we're writing that down is it's given to us. Second thing, we have a little freedom. We just got to kind of look and have a plan and how we're going to approach this. The two triangles share a side, BD, and so we can say that BD is congruent to BD. That's our reflexive property. We can also say that AD is congruent to DC because BD bisects AC. So definition of a bisector. A bisector means it actually cuts that in half, and so BD cuts AC in half. So D is that midpoint, so AD and DC are the same length. For a statement, we can say that both angle ADB and angle CBD are right angles. And thus they're congruent to each other. So angle ADB is going to be congruent to angle CDB. And the reason is definition of perpendicular. Okay, perpendicular means a right angle, and so we know BD forms a right angle with AC. So both those angles are 90 degrees, so they're both the same, they're both congruent. So looking at this, we can now say or conclude what we're trying to conclude. Our last statement is that triangle BAD is congruent to triangle BCD, and the reason we're using the side angle side. Number 20, given a second proof, given BD is perpendicular to AB and BD is perpendicular to DE and BC is congruent to DC. We want to prove that angle A is congruent to angle E. So again, let's start that two-column proof. Statements on the left side, reasons on the right side. And our first statement is just to list the givens. So just copy down what's given. So BD perpendicular to AB, BD perpendicular to DE, BC congruent to DC. And the reason is it's given. So then let's take a look at our picture here, see where those things fall into place. So BD perpendicular to AB, so that's why we see that right angle here. Also BD perpendicular to DE, we see another right angle put there, and then it's marked BC and DC are congruent. Also looking at the picture, we have vertical angles, and so for our second statement we can say that angle ACB is congruent to angle ECD, since their vertical angles are congruent. And now we can say that the two triangles are congruent by angle side angle. So triangle ABC is congruent to triangle EDC, by angle side angle. And since the triangles are congruent, all their corresponding parts are congruent. So now we can get what we're trying to prove, that angle A is congruent to angle E, since corresponding parts of congruent triangles are congruent. We have another proof. Given angle, well, let's write those givens. So we have our statement. So angle WVZ and VWX are right angles. And they also also let us know that WZ is congruent to VX. Those are given. Look at the picture, we can see a little bit what's going on here. But notice in our picture we have the overlapping triangles, and so I'm going to separate those overlapping triangles. Whenever you have overlapping triangles, it's always a good idea to separate them. So the one I outlined in blue, I'm going to move over here, ZVW, right angle, and then the second one, tracing in green here. XWV. And overlapping triangles either always share a side or an angle. In this case, they're sharing a side, VW, so I'm going to mark that on both of them. And let's put that in our second statement, that VW is congruent to VW by the reflexive property. We can also say that angle V is congruent to angle W since they're both right angles. And then we haven't marked this yet, but in the given we have WZ is congruent to VX. And both these are right triangles, and we have they both have congruent corresponding congruent hypotenuse and corresponding congruent legs, and so we can say that the triangles are congruent by hypotenuse leg. So our last statement, triangle WVZ is congruent to triangle VWX by hypotenuse leg. Number 22. Start again with our statement reason, two table or two column proof. So our givens, angle 1 is congruent to angle 2. WX is congruent to ZY. Here we have two triangles in one. Our reason for statement 1 is given. Let's mark what's given here. So angle 1 is congruent to angle 2. Because angle 1 is congruent to angle 2, if you look at the large triangle, triangle WPZ, we get that that's an isosceles triangle. So for a second statement, we can say that WP is congruent to PZ, and the reason is the converse of the isosceles triangle theorem. We also have another given. We're given that Wx, I'll highlight these, so Wx is congruent to Zy. So if you look at the two smaller triangles on the left and right side, we have triangle WPX, and I'm going to claim that that's congruent to triangle ZPY. Can you see why? Third statement, third reason, we have side angle side. And because those two smaller triangles are congruent, all their parts are congruent. And so I'm now going to focus in on the middle triangle here. I want to show that angle 3 and angle 4 are congruent. And I can do that by showing that that middle triangle is isosceles. So my next part here is going to state that XP is congruent to PY, because those are parts of the smaller triangles, right? XP is part of the smaller triangle on the left side, and PY is part of the smaller triangle on the right side, and those smaller triangles are congruent to each other, and so we have that those pieces are also congruent. And so let's state that. So PX, line segment PX, is congruent to segment PY, because, you know, using statement 3, we have those two smaller triangles congruent to each other, and so statement 4, we have that corresponding parts of congruent triangles are congruent. And now we can finally get to what we're trying to prove, which is that angle 3 is congruent to angle 4. And the reason is the isosceles triangle theorem. Number 23, we're going to write another proof. So statement reason. Start with the givens. So first statement, we have the angle PSR and angle PQR are right angles. And we also have that angle QPR is congruent to angle SRP. We want to prove that triangle STR. I'm going to outline this. And I don't see a T on here, so I'm going to assume T is dead center here, okay? So STR want to prove STR is congruent to QTP. So that one congruent to that one. Okay. And they give us a plan for our proof. So they're saying first prove that triangle QPR is congruent to SRP, and then prove that triangle STR is congruent to QTP, which is what we want to originally do. So it's saying first focus on the other two. So instead of doing the ones I'm highlighting, okay, let's do what they're first telling us to try to prove. So right here in green, prove this first in our plan. QPR. So that one right there. Congruent to SRP. Okay. So let's do that. Well, we're given that angle PSR is 90 degrees, and you see it drawn in there. Angle PQR is also 90 degrees, not drawn in. And so we could say that angle PSR is going to be congruent to angle PQR. Our reason, they're both equal to 90 degrees, or their measures are both equal to 90 degrees by definition of a right triangle. Or sorry, right angle, not right triangle. Also notice that they share a side. Where the green is highlighted and the yellow is highlighted, they both share side PR. So number 3, we could say PR is congruent to PR. That's the symmetric property. I'm sorry, the reflexive property. Number 4. Alright, so we have angles congruent, we have the side. Also given to us is angle QPR. So that's this angle here, is congruent to angle SRP, this angle right here. So these are let's see, angle side congruent. So we have enough now to prove that triangle QPR is congruent to triangle SRP by angle side congruence. Alright, so that's not the goal of our proof, but that's the direction we were told to take. So now that we have that, now let's see what we're trying to do. I'll highlight it in purple. We're trying to show that these, it's getting a little messy. Let me erase some stuff. So we have those two larger triangles congruent. We're now trying to show that these two triangles are congruent. Okay. Well, from our first statement, from 4, we can say that PQ, or QP, is congruent to SR. because the two triangles in 4 are congruent, and so we say corresponding parts of congruent triangles are congruent. Okay, and so we have this is congruent to this. Let's see, what else do we have? We have vertical angles congruent. So I'm running out of space here. I'm going to continue my proof over here. So number 6, we'll say angle STR. T's the middle here, I kind of wrote over it, so TR is congruent to angle QTP. And our reason is vertical angles. Are congruent. So now, if we look at 6, 5, and the given, right? Because that given is also still in there. I'll draw it in blue, so you remember where it is here and here. Okay, we have congruence by angle side again. So we have finally made it to step 7. We're trying to prove that triangle STR is congruent to triangle QTP by angle side congruence. Number 24, find a congruence transformation that maps triangle ABC to triangle DEF. So in 24, we want to match up that triangle ABC with DEF. Notice the ordering of the letters. So point A, we want that to, A is the first letter, right? We want that to match up with the first letter D, so that's going to end up where point D is. And point B, we want that to match up where point E is, because those are the second letters. And there's one left, so point C is going to end up where point F is. We have 3 different types of transformations to use here. We can use reflections, we can use rotations, we can use translations. Okay. No matter what, we're going to have to do some kind of rotation here, and possibly even a reflection. So there's a couple different paths we can take. The first thing I'm going to do is try to, let's reflect. Remember, we went from ABC to the other. So first step, let's reflect across the x-axis. Sorry, the y-axis. So to do that, you pick a point. Let's say point C. Point C is 1 unit to the right of the y-axis, so we're going to move it 1 unit left of the y-axis. Point B is 2 to the left, so we're going to move it 2 to the right. Call this C prime, this is B prime. And then A is 1, 2, 3, 4 to the left, so we're going to move it 1, 2, 3, 4 to the right. And I'll call that A prime. Connect those. Alright, and still I'm going to color, so I want A prime again to end up where D is. I want B prime to end up where E is, and I want C prime to end up where F is. And I'm just gonna, so I don't have too much color on here, erase the original highlights. Okay. So now I'm going to, let's say our next thing here is going to be a rotation. The second step, rotate, and let's go 90 degrees clockwise about the origin. Or about the point 0, 0. To make this rotation, take a point, so say C prime. To go from 0, 0 to C prime, I go up 2, left 1. So if I'm going to rotate it 90 degrees to the right, I'm going to go right 2, up 1. So that's the location of my new C double prime. I'll change the color here. It's getting a little messy here, but that's where C double prime is going to be. To see that it's a 90-degree rotation, if you were to draw, from 0, 0 to that point C prime, and then from 0, 0 to C double prime, you can kind of see that that's a 90-degree angle. Another way to think about this is slope. Like the slope from 0, 0 to C prime is up to left 1, so it's a negative 2 over 1. And if you remember a slope perpendicular to that, you take the opposite of that, so it's positive, and you take the reciprocal, so 1 over 2. So from that point, I go up 1, right 2. So that's another just confirmation that we're rotating this thing 90 degrees. Okay, so I'm going to erase that part. Pick another point, say B. To go from 0, 0 to B, you're going up 1, 2, 3, left 2. So I'm going to go right 3, up 2. Is that right? Well, I'm going to the wrong point. I went to point B, not to B prime. That's throwing me off. Too many letters here. We want to go to B prime, not to B. So to go to B prime, we're going up 1, 2, 3, and right 2. So I'm going to go right 3, 1, 2, 3, and down 2. And so that is going to be where B double prime is. And A prime, you go up 1, right 1, 2, 3, 4. So we're going to go right 1, down 1, 2, 3, 4. And when I connect this, here's where we're at. So we are almost where we need to be. And you can probably see everything's in the right position. We just need to move it over 1 unit to the right. And we say translate. So the third step, translate 1 unit to the right. And those are the 3 steps we need to do to make or find that congruence transformation that maps triangle ABC to DEF on number 24. On number 25, one way to go about this is to, first step, reflect across the, doesn't matter, let's do the y-axis first. I'm going to end up doing both. This is point B here. And when we reflect it across the y-axis, we find a point say point A is 2 to the left of the y-axis, so we go 2 to the right. Call that A prime. And C is 2 to the right, so I'm going to go 2 to the left. C prime. And B is at the same location as B prime. Second step, let's take our image there and reflect that across the x-axis. So C prime is 2 below the x-axis, I'm going 2 above, so that's my C double prime. B prime is 4 below, so I'm going 4 above, that's my B double prime. And A prime is 1, 2, 3 below, so I'm going up 1, 2, 3 above, that's my A double prime. So here is my result. Almost exactly where I want it. Last step, translate 2 units to the right. Alright, number 26. Here we were supposed to complete the following proof, so they've kind of led us through some steps here. We're given that RU, well, first statement, we know is the given, right? But let's kind of draw in, or just look at our graph, study it a little bit, see what's given to us. So we know that RU is congruent to TS. So RU here is congruent to TS. We also know that angle RUT, okay, this whole thing here, is congruent to UTS, right here. And, well, I guess we don't directly know they're congruent, but we can get there. They're both right angles, and so I drew that wrong a little bit. So let's draw on the right angles. Gotta keep reading here. Okay, so right angle there, right angle there. V is the midpoint of US. So that would mean that UV is the same length as VS, because V is the middle. Alright, so let's see what's gone on so far in this proof. They stated the givens, now they're saying UT is congruent to TU. Well, that's the same length, so that's right here. It's congruent to itself, that's the reflexive property. Third statement we need to come up with, but we have the reason all right angles are congruent. So, well, there's 2 right angles we drew in there, so that would say that angle RUT is congruent to angle STU, or UTS. Statement 4 we don't know, but we know the side angle side. Okay, so what's above in statement 1 through 3 should reveal side angle side for some pair of triangles. So let's see, they're sharing a side here. That's the reflexive one. We have just previously stated, we have UT and TU. We got, what else is stated? RUT. So the angle, right? This right angle and this right angle are the same. And we have that RU is the same as this. So what triangles would those belong to? Well, here's one of them. I'll color it in. So this right triangle here Got side angle side for that one. And the other triangle is this one right here. Okay, so saying that they're both congruent by side angle side. So triangle URT congruent to triangle, well, U is where the right angle was, so T is where the right angle is for the other one. And then U to R is the distance was 1 dash, so T to S, and then to U. Okay. Next, 5 says angle RUS. So I'm going to go back and see what we can get here. So RUS is congruent, well, RUS and SUT are complementary angles. That's true. Both those angles make 90 degrees. So our reason here for 5 is the angle addition postulate. Number 6, we don't know the statement, but we have definition of complementary angles. Okay. So complementary angles. Well, the definition of a complementary angle is that the two measures, so the measure of angle RUS plus the measure of angle SUT is going to add up to 90 degrees. 7, angle SUT is congruent to angle RTU. So let's find those. SUT okay. We've already drawn that in. That's right there. Is congruent to RTU. Right there. And that we've already established by number 4. SUT is in the second triangle, and RTU is in the first triangle. And because we have two triangles that are congruent, their corresponding parts are congruent. So corresponding parts of congruent triangles are congruent. Okay. Angle RUS, okay, that one right there, is congruent to angle STR. Well, if you look in statement 6, from statement 6, the measure of RUS plus the measure of angle SUT is equal to 90 degrees. So I'm going to write a few things here. In 8, I'm going to write the measure of angle RUS is equal to 90 degrees minus the measure of angle SUT. Okay, that's just a direct result. So 8's coming from 6 here. Okay, so we're pointing to 6. And then in 7, we said SUT is the same, is congruent to RTU. So we can also say that this is the same as 90 degrees. I'm going to substitute, instead of measure of SUT, I'm going to put the measure of angle RTU. And if you look at the picture, 90 minus RTU is what we see as the measure of angle STR. And so because the measure of RUS is equal to the measure of angle STR, we say that those angles are congruent. A little tough to come up with there. All right, 9. We're using a definition of a midpoint in your original given that says V is the midpoint of US. And so we said UV and VS are congruent. So UV, line segment UV is congruent to line segment VS. 10, angle RVU. I'm going to use red here. That angle is congruent to angle TVS. Okay. Vertical angles are congruent. And we made it to the last statement here. Triangle RVU, I'm going to highlight that one. Triangle RVU, okay, is congruent to triangle TVS. So let's see. What is telling us that? Obviously, we got our vertical angles in 10. We have our midpoint in 9 that gave those sides. And then 8, we've established those angles. So angle, side angle, congruence. Yay, we got through that. 27. Translate triangle ABC down 4 units and right 5 units. Label the new triangle A prime, B prime, C prime. Okay, so down 4, right 5. So I'm going to take point C, down 1, 2, 3, 4, right 1, 2, 3, 4, 5, and that's my new C prime. Do that with A, down 4, right 5, we end up here. And do that with B as well, down 4, right 1, 2, 3, 4, 5, about right there. And draw that triangle in. Part A done. Part B, reflect that triangle over the line y equals -1. All right, so first of all, where's the line y equals -1? That's this line right here, the horizontal line. And if you pick any point on this line and look at its coordinate, its y value is always going to be -1. All those points on that line are stuck at the height, -1. That's why we say that's the line y equals -1. So we want to reflect this across that line. So B prime is above that line 1 unit, so we're going to go below that line 1 unit. A prime is below 2, so we're going to go above 2. And C prime is below 2, we're going to go above 2. And here is our result. And we're going to label A double prime, oops, A is over here, B double prime, and C double prime. And we made it. 28, rotate triangle PQR 270 degrees counterclockwise. Okay, so counterclockwise going this way, 270 degrees. Well, if we go 270 degrees counterclockwise, that's the same thing as going clockwise how many degrees? 90. Why? Because a full circle is 360 degrees, and if you go 360 minus 270, you get 90 left over. So it might be a little easier to visualize rotating clockwise 90 degrees, and we get the same result, so let's focus on that. So as we rotate, we're going to do 1 point at a time. Okay. Start with the easiest point first. Point Q. If you take that point, rotate it 90 degrees, I think you can see that we'd end up at negative 1, 0. And we're going to label that Q prime. Okay. The other two may be a little harder to see, but point P, if you look at its reference from the origin, we'll go down 1, 2, 3, 4, left 1. And so we're going to go from the origin left 4, up 1. 1, 2, 3, 4, up 1. And call that P prime. Let me show you another way. So point P is at the point negative 1, 4. Negative 4, sorry. And if you compare that to point P prime, we are at negative 4, positive 1. And so what's happened here is for a 90-degree clockwise turn, we've swapped, in a sense, our x and y values, and we made our, the negative 1 went from negative to positive, and that resulted in our 90-degree turn. You can do that same thing with R. Point R is at 1, 2, 3, down 1, 2, 3, 4. So following a similar pattern, where do you think R prime would be? Well, you swap them. And that 3, you're going to make a negative 3. Let's see where that point is. Negative 4, negative 3. Right there. And that's the correct result. That's where R prime is. There's our 90-degree clockwise, which is 270-degree counterclockwise. Okay. So done with the first step. Part B, reflect that image over the y-axis. So y-axis, Q prime is 1 to the left, so we're going to go 1 to the right. That's Q double prime. P is 1, 2, 3, 4 to the left of the y-axis, so we go 1, 2, 3, 4 to the right of the y-axis. And R is also 4 to the left, so we go 4 to the right. Same height. And that is our reflection across the y-axis. (29) Given a triangle EFG is congruent to triangle XYZ, find the measure of angle X. Okay, measure of angle X is here, and X is the first letter, so that's congruent to E. So we know that angle X, or the measure of angle X, is equal to the measure of angle E. So I'm going to mark that in here. And we know that the measure of angle E is, well, I think we can get 30 degrees by looking at it, but if you can't, let's call that X. X plus 60 degrees plus 90 degrees is your 180 degrees, because all three angles inside the triangle add up to 180. Where to end up here? Hold on a sec. 60 plus 90 is 150. And subtracting 150, you get x is 30. So 30 degrees is our answer. For 30, notice that we have an isosceles triangle. Those two sides are the same, so by the isosceles triangle theorem, these two base angles are the same. And so x is 68 degrees. For 31, nothing seems obvious yet, but let's find our missing angle. Let's call it angle x for right now. Oh, don't use x, actually. X is already used. Let's say angle y. Y plus 58 plus 64 is 180 degrees. 58 plus 64 is, so 8 plus 4 is 12, carry the 1, and you get 122. Subtract 122 from 180, and you have 58 degrees. So we got 58 degrees here. So both these angles match. So by the converse of the isosceles triangles, these two sides should be equal to each other. So 4x plus 12 is equal to 3x plus 17. Subtract x from both sides, you get x plus 12 is equal to 17. And then to subtract 12 and you get x is equal to 5. And there we have it.